So this is a t-shirt from you people, great folks. It's about
great folks.
Platform engineering for the win.
Yay.
Thanks a lot for this t-shirt. And I also have the other one, the one with the croissant.
Oh, wow.
Yeah, the only reason why I didn't wear it is because I thought that Luca will
wear the croissant one.
Yeah, and Luca usually have the background, like I have the bright background. Usually Luca has the dark background. So if I put like white with, it doesn't fit together. But I really like the croissant
croissant t-shirt. Oh my God, that's so exciting. I should come more prepared. I should have a different set of t-shirts as well. I'll make sure it's we think of it for the next webinar, but for this one, I have no other notes. Hila, over to you. Welcome again.
Cool. Thanks, Maria. So I'll share my screen. Okay, so first of all, just excuse me if I cough a bit because I'm recovering from getting cold. So if I cough, just ignore that. Okay, so Terraform practices. I'll talk about Terraform, which is a great tool, right? And it is used widely across the world. And this talk will cover not only specific bits and pieces regarding Terraform usage and practices, but also hopefully will make you think about your unique use cases and scenarios and help you see the big picture and utilize Terraform in a broader context rather than just an infrastructure as code tool. And that way you'll be able to scale up your infrastructure and your teams who will use a Terraform. Just a sec. Okay, so let's start. So first of all, let me introduce myself. Hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. Recently, I have joined the AWS Community Builders Program, which is an awesome program that allows me to connect with like-minded people about AWS stuff, but also learn about AWS services more in depth. I help co-organize conferences about DevOps related topics in Israel, where I live, DevOps Days Tel Aviv, and StatsCraft, which is a monitoring conference. I'm a mentor in courses and communities. I'm a DevOps culture fan. I think this is what helps companies achieve great things. And I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so let's talk about Terraform implementations. And basically, they could be good, bad, and ugly at times. And one disclaimer before I start, first of all, most examples that I'm going to show here are from AWS, but of course, Terraform works with any cloud provider out there. And I'm only covering Terraform in the open source edition because I haven't worked with the cloud or enterprise. So I assume that stuff that I will cover here is implemented differently for cloud or enterprise. So just bear that in mind that this is mostly about all about Terraform open source edition. Okay, so let's start with quick wins. And when I say quick wins, I mean low effort, high value things that will help you scale better and more efficiently and prevent refactoring and extra work later on. And basically, these are things that you can really achieve in a matter of minutes or very short time that will help you leverage Terraform in the best way possible. So versions lock. Same as for requirements TXT for Python or package lock JSON. So we can lock versions for Terraform as well. We can lock modules, providers, and Terraform versions. And when I say version in Terraform, it basically means the set of features and expected syntax in that version. So these are the ways to lock the versions for each one of them. And the thing about locking the versions, this is a meme by Anton Babenko. If you don't know him, he's a pretty celeb in regards to Terraform because he's the main maintainer of Terraform AWS modules, the community models that I will cover more in a bit. And this meme, as you can see, state that sometimes we have issues with the providers and it is a known, right? And we need to be aware of that and lock versions because that way we at least deal with the development that we know and not expect any unknowns because we don't lock versions. At least we know that if there are any issues, they are bounded in the version that we chose to work with. So in regards to versions lock, we should always lock modules, providers, and Terraform versions. The bad thing is to lock in a way that will still allow breaking changes to go through, because if we will lock to a minor version as opposed to a major version, then maybe breaking changes will still go through. And the ugly thing is to have no versions lock whatsoever. Trust me, you will have syntax issues, you will have a lot of problems. So just try to avoid that. And the thing about consistent versions and no conflicts or breaking changes is that it's the fact that it will allow and help your teams in the long run, which is an awesome thing to have. The next thing that I want to cover is tagging resources. So for me, it is a must implement practice, because it will allow you to filter your cloud provider expenses and sort them based on tags to distinguish between resources. It will allow cost control in other tools like Datadog, for example, that use tags for that. You will gain visibility on ownership and overall projects by tagging according to a logical breakdown. And the most important thing is that if you have a FinOps team, the team that is in charge of cost management, they will be very happy if you tag your resources. And if you don't have FinOps team, then congratulations, you are the FinOps team. So we always need to think about cost management, and tagging resources is the way to go. So I've put here some examples for tags that we use in Wix for tagging the resources. And also Terraform allows setting up default tags. For example, in AWS, you can set up default tags for this provider. And then when I say default tags, it means that every resource that you create under this provider, aka every resource in AWS, will get automatically this tag. So it's good to have, for example, the managed by Terraform tag here. And that way you just set it and forget about it. It will be populated and propagated for any resource that will create it in Terraform on AWS specifically, and that's basically it. So the good thing is to tag everything, really. It will be the best thing. You should use default tags, as I just explained, because that way you will reduce code repeatability and you wouldn't forget setting up tags. And another good thing is to set up a PR enforcement, in which if someone introduces a code and they forget to add tags to the resources, then the PR merge will fail. And I will cover the PR enforcements later on. The bad thing is to tag inconsistently, because as we know, consistency is key. We can't set up automations if we want to. We can't really track our projects if we tag inconsistently. So please try to avoid that. And the other thing is to really have no tags whatsoever. No cost management, projects will be hard to track. So really try to avoid that. The next and last thing in the quick win section is remote state. So by default, Terraform works with local state, and remote state helps scale your team because everything is remote and you have one source of truth. So this is a way to set up remote state in a S3 bucket. And basically, but as I said, you can do that for any cloud provider. So the good thing is to have your state remote and secured, to have it backed up, because if we don't have it backed up, then we might face issues, and we can't really restore it without that. It will be very hard to restore. So that's about that. And to have the Terraform state lock, you can leverage a DynamoDB for that. So it means that if I run Terraform, while I run it, there will be a state lock. So if someone else tries to run Terraform on the same state file at the same time, it will say, sorry, someone else is running it. The state is locked, please wait, and then it will get run. So this is awesome to have. And remote state, again, it allows scaling across teams. And also think about it this way: even if you're the only person dealing with Terraform, still go with remote state for the sake of backups and redundancy. And the bad and the ugly is pretty much the opposite. So to have local state, or to have the state remote but not secured or backed up, and to have no state lock during Terraform apply. So this was about quick wins. things that you can achieve in a matter of a very short time to have a very good leverage of Terraform for scaling or any other purposes. And before I go to the next section, Maria, are there any questions?
Yes, there are actually 3 questions. I guess the first one, Broder asked just when the webinar started. I don't know if you want to keep it until then or answer now, but to read it out, would be awesome if you could give examples of how one can combine the count argument that depends on resources where Terraform doesn't know the amount yet, because they are also going to be created. An example could be that I want to create an AWS VPC resources, and in the same Terraform plan apply also add one root to all created root tables from the VPC resource.
Okay, it sounds a bit complex for now, and explaining it without showing a code for that will be a bit problematic in my opinion, but this person can reach out to me afterwards, and I'll be more than happy to help. I will put my details at the last slide. So I don't have like a go-to right now. I need to think about it, write some code to make sure. I will address it better afterwards.
Yeah, and there are another 2, but Broder also mentioned that we can discuss it in the end of the webinar. So please continue.
Okay, cool. So now I want to go over to second nature. And when I say second nature, I mean day-to-day awareness that will help you reduce refactoring code in the long run and prevent time waste and basically align to best practices as much as possible. So the first thing is using community models versus creating them yourself. There's a saying, right? Why reinvent the wheel? A lot of well-known cloud providers features are already covered by modules. So just do your research and check available modules before implementing yours. And another thing about using community models, it's very good because they are proved over time. They are supported by the community. You eliminate the need to support it yourself and keep it up to date because there are other people doing it for you. And community models usually use enforced linters, formatters, and logical checks, allowing new users to get easily involved, contribute to this model, and use it while preserving a high code quality and basically making the modules more robust in the process. So these are the reasons why we should use community models if possible, right? If it fits our use case. So the good thing is to use verified community models where possible, because if it doesn't fit your use case, then don't try too hard, and only if it fits your use case. And when I say verified, I mean that lately Terraform, HashiCorp, the company that created Terraform, they removed the verified label from the modules in the Terraform registry. So so we don't have the ability to know if they are verified or not, but at least we can check the amount of downloads of that modules. And then if a lot of people download it, probably they are safe to use. The bad thing is to use custom models, but if you still maintain them in a good way, AKA, this is the bad. So if you have custom models, while community models exist, that's not that great, but at least if you have a proper maintenance for that, if you have consistent checks and code practices applied, that's good enough, but still, why reinvent the wheel, right? Just use community models wherever possible. And another bad thing is to have a community model used without version lock because of the reasons that I explained at the beginning. And the other thing here is to use a custom model and unmaintain it, right? So have no checks, no consistency whatsoever, and no code practices. It will really get ugly and really get out of control. And another thing is to use unverified community models, because that way you will potentially introduce malicious configuration to your environment, which is not good at all. And the thing is that if you do have to create your own models, then make sure you make them stateless and clean as much as possible, aka they are generic. You do not repeat yourself if you don't have to. The code is kept simple as much as possible for the sake of readability and cleanliness of the code. and enforcements are there to maintain quality. I know that I'm creating a build-up towards the practices enforcement, but I will get to it, don't worry. And just we need to remember that community models usually have these enforced linters, formattings, and logical checks because they want to maintain important aspects to allow the users to get easily involved, as I said before. And you should apply the same principles on your internal modules as well. And again, I will cover it in a bit. The next section that I want to cover here are variables versus locals. So unlike variable values, local values can use dynamic expressions and resource arguments. Locals also don't change values during or between Terraform runs, such as plan, apply, or destroy. So you can use locals to give a name to a result of any Terraform expression and reuse that name throughout your configuration. So for example, as you can see on the slide, we can have variables for project and environment, and then we have a local that merge these variables with other required tags, and then we have a final definition of tags, and then we can reuse it throughout the module once, and that's it. So for using variables on the module side, you should use it like a setting, right? Setting for the module configuration, but make sure that you set up a default or validation, right? Because if you don't set up a default or validation, like in this example here, then if someone uses this module and doesn't pass the values for the variables, then the module will break, and we don't want that. And in regards to locals, you should consider it as a constant to be honored or relied on. So for example, if we have a module to create S3 buckets, I can set up naming convention for the buckets and have them all in the same naming conventions and set it in locals. And then everyone that uses this module, we can just is bound to that naming convention, which is a good thing. We want to bound it to have a structure of the buckets to make sure we know exactly which buckets are ours, and etc. And just in regards to this specific example of naming convention, just always think about limitations of your cloud if they have a characters limit and stuff like that. So we need to bear that in mind once we set these definitions. So this was on the module side. On the live side, and when I say live, I mean where we call the modules. So modules are like class in code, and live is the instantiation of the class. So on the live side, for variables, if the variables are used once, so just set a default and that's that. But if you use them per region, etc., then use TFR files for each region. And in regards to locals, you should really avoid using locals because we want to keep the live side as simple as possible and leave the logic to the module side. And also you should use data sources to pass their outputs to modules, because that way we have a dynamic configuration that is getting fetched. And that way it's good because we always want the last updated configuration, and data sources will help us do it because it is dynamic. So the good thing about variables and locals is that you can use diff vals whenever necessary. You can utilize environment variables because these are basically like built-in variables, and then it prevents the need to add more variables because you can just utilize these and that's it. Use locals to hard code one-time names and decrease code repeatability, and just have a notion of keep things as generic as possible. The bad thing is that Terraform allows to have multiple locals block. So don't use it if you don't really have to, because then maybe people will put it in different files and then it will be very hard to track and maintain. So if you don't have to do it, avoid that. Decentralize variables. So I will cover a file structure in a bit, but basically keep all your variables in one file. That way it will be easier to maintain. And ignoring environment variables is also not good, because that way you need to create more variables to compensate for that. And the ugly thing is to hard code variables values were not necessary, because this is exactly it, right? Variables, they need to vary. So if you don't need to hard code, really don't do it if you don't really have to. The next section is file structure. So as we know, Terraform executes all files with the .tf extension, the suffix. But for better logical arrangement and easy management, we should have a file structure with naming convention. And we can take example from the community models as well. So in community models, we have this structure. We have main TF, which holds the main logic of that model, and then variables for the variables, data for data sources, and versions for the providers versions, the Terraform version, etc. And thing about this is that we should have, it's best to have naming convention which reflects the actual purpose of each file. That way you will get a decent logical arrangement for faster access, better readability, and cleanliness of the code. So for example, if we have a complex main TF, we should break it down. So let's take, for example, a module that creates a virtual machine. The resource to create a virtual machine is in main TF, but if, for example, we need a load balancer for that machines or security groups, then we should break it down to different files, and then we can know exactly what is kept in which file and have a better readability for that. And in regards to breaking things down, if, for example, you create a model of your own and you and the model is pretty complex, then consider breaking it down to sub-modules. So this also can be an example from a community. So EKS module has a sub-module of creating the node pools, and the VPC module has a sub-module of the VPC endpoint. So the breaking it down to sub-modules is good because that way variables would be bound to the module and the sub-modules, and then the variables file wouldn't be that gigantic to maintain. And also that way you can reuse sub-modules independently. Because if I want to use, for example, from the community module, only the VPC endpoint, I can do that. So, so just have this all bear in mind, because we want to have a better arrangement of the code and to reuse it as much as possible. Okay, we reached the, I think this is my favorite part of this presentation, applying a classic code best practices on Terraform. So before you jump the gun, I know and everyone knows that Terraform is not a pure programming language. That's okay, we all know that. But similar rules of writing code apply to Terraform as well. Terraform progressed over the years in a way that adopts code best practices, and we can see an example for that. So you might remember that before Terraform 0.13, you can't even use for each for modules. And with the release of this version, HashiCorp finally introduced the ability to loop over modules with a single module call. So that way we should really apply classic code best practices to Terraform, and which means that Terraform should be kept in source control management like GitHub, GitLab, Bitbucket. Keep the code as simple as possible. Do not repeat yourself if you don't have to. Even principles of functional programming can be applied on Terraform. The code should be idempotent. And in regards to human and clean, I want to quote something from an article by Tisin Uo. I will have a reference slide at the end, so you will have a link there. It's a very good article. I really recommend you to read it. So he said, and I totally agree, that the computer that processes your code doesn't care if the variables names are ambiguous or inaccurate. If used correctly, it will still get executed, right? But since human beings are the ones to maintain the code, we need to make sure it is readable. So things like refactoring, clean code, naming conventions, etc., are invented so the humans can read the code better. So for the sake of us humans and not for computers. So please make sure you apply a classic code best practices as much as possible on Terraform, because it will be easier to maintain, easier to read, and easier to scale in the long run when we need to get to it. Okay, so before I get to the last section of the presentation, do we have any questions?
We have a ton of questions, but I'm not sure if that's the best way to keep them till then or answer now, because they're from different sections. I don't know, guys.
Okay, we can keep them all to the end, no problem.
Yeah.
Cool. Sorry about all the coughing. Okay, so the last section that I'm gonna cover, let's do a quick recap. So we covered quick wins, things to achieve in a matter of seconds, minutes, or very short time to leverage Terraform in the best way possible. We talked about second nature, things to think about in your day-to-day when you work with Terraform. Let's talk about the long haul. So in a company, we need to collaborate, we need to add resources, we need to scale, right? So for different teams working on the same infrastructure or doing audits, for example, on that infrastructure, considering the long haul practices will allow them to have the needed visibility on that infrastructure. And it also allows them to isolate environments and their changes and effects, and scale Terraform usage by teams and the infrastructure itself more easily and efficiently. And before I will show the practices themselves, I want to ask you one question. How do you envision the infrastructure and the company's needs? And this is a very important question because we really need to think things through and do what's best for the company's needs and the infrastructure use cases. And I will tell you so about it to emphasize that. So in one of my daily syncs at work, I work for the DevOps team in the data engineering group. So I help dev teams. I provide infrastructure for their data tools. So one of them is Presto, which is a tool to query data. So until now, we have Presto installed on a fleet of machines with auto-scaling group. So basically a cluster of VMs. And then on one of the daily syncs, we raised a suggestion to move Presto to Kubernetes. And then all my team members were like, yeah, let's move to Kubernetes. Yeah, let's do it. We want Kubernetes. Okay. They were very, very excited about that. And the thing is that before I reacted to that, I thought between myself and me and myself. And I thought about the fact that, yeah, I want to move to Kubernetes as well, right? Because a lot of companies adopt Kubernetes. And if I will practice Kubernetes more, because I already worked with Kubernetes, but as we know, Kubernetes is very complex and there isn't enough. I know enough. It's very complex and learning more and more will only help you. So if I will work with Kubernetes more, it's good for me because it will make me more valuable for other companies later on in my career when I decide to leave. So it's beneficial for me in my career. But at that point, I stopped and I didn't say that. And I thought about the infrastructure and application needs. And then I said, wait, we need to think about if Presto even can work on Kubernetes. Maybe there aren't production use cases that we can find online to make sure that it is the best infrastructure suitable for the application. So we need to think about use cases. If there are production use cases, we need to think about to check if there are any known issues that we need to avoid. So this is exactly it. I want what's best for me, but in that point, I stopped and I thought about the company's needs and the infrastructure needs. And I really encourage you to do this as well. Drop the buzzwords for now. Kubernetes is great, but if you don't really need that, don't do it. If you need to utilize Terraform in ways that is suitable for your use cases, please do that because this is the best thing for your company's needs and for your infrastructure needs. So because we planned things ahead, we thought things through in weeks. Hence, we decided to use Terraform and structure the code base in a way that made sense to us, and I believe will make sense to you as well. If infrastructure and team scaling is something that you see when you envision the infrastructure and companies' needs. So this is a structure that really suits our needs especially for scaling. So we have this structure in weeks. It starts with team, and then project, cloud provider, and region. One implementation for that is, so we have live and modules, and then BI for team, Airflow for project, AWS for cloud provider, and then US East 1 for region. And why did we choose to do this structure? 2 reasons. First of all, Terraform as a platform, okay? This is a very important thing to have because if we set up Terraform as a platform, we enable other teams to onboard to the same repository, okay? Because we have one repository, all teams are on that repository, and then everyone can just onboard and use Terraform out of the box with modules that already available for them to use with references and everything. Another thing is that we leverage code owners in GitHub, so that way they have complete autonomy of managing their own folder, because code owners, we define it for the pull request review, and then we define each users or groups in GitHub who can approve the PRs, and that way they have a complete autonomy. And also practices enforcement, again, I'm mentioning it, but I will get to it very, very soon. We have practices enforcement done on the repository, and it's getting applied to any code that you introduce to the repository. And that way we can make sure the code is in a high quality state. So this is one reason why we chose this structure. Another reason is to have small state files. So I hope that you know, Terraform creates a dependency tree between the resources based on logics of their own. And sometimes Terraform doesn't create the best dependency tree. And then you will have invalid dependencies, which means that I can change a tag, run Terraform plan, and see that Terraform is going to destroy a resource. And then why? I just added the tag. What's going on, right? So that's exactly it. If we structure the Terraform codebase in a way that will have huge state files, then huge state files will have big blast radius because of the invalid dependencies, and it's very hard to overcome that. So this structure that I just showed you here allows us to have small state files. And why is that? Because the state file is in that level, in US East 1. So it means that the state file only consists of Airflow resources for the BI team in AWS in US East 1. Okay, so it's very, very contained. And as if you set the structure in a way that will have small state files, then you eliminate a big blast radius and minimize invalid dependencies as much as possible. So these are the two main reasons why we chose this structure, which is a very good thing to have, mostly because when you need to scale your teams that use Terraform, or when you scale the infrastructure itself. The next thing I want to cover here is workspaces, and I cover the open source again. I just want to remind you about it again, because workspaces in Terraform Cloud, for example, is a whole different thing. So workspaces in open source edition is basically to have an isolation of states. So if you run Terraform plan, Terraform will not see any existing state of any other workspaces, only on the one that you work with. So when should we use workspaces? For example, when we have the same Terraform config, but for different customers, like let's take GCP now as an example. So if we have different customers as different GCP projects, each one will be a different workspace of its own. Coupled with that, if all customers need to use the same service, like financial service or login service, then this one can be in workspaces as well, because financial service in region Europe and then United States, etc., then workspaces can be used for that as well. Some notes about workspaces, though, is that you should really consider using a Terraform wrapper while you work with workspaces to avoid human errors. And why is that? It's because how we work with workspaces. How do we do that? With CLI, Terraform workspace select X. If I forgot to do this select, production incident, okay? So just in order to avoid that, have some sort of a wrapper. You can create like a mini system with Python that will handle the switching between workspaces for you. That way you don't forget anything and no incidents and all good. Other than that, you need to think about the fact that you have less visibility when you work with workspaces, because even if you use a Terraform workspace built-in variable, a conditional that can be used, even if you use that, still it doesn't mean that all workspaces that are available are really used. So because I can do Terraform workspace list, see a lot of workspaces there, and maybe they are not really in use. Maybe someone created that, forgot to delete them, and that's that. So you have less visibility. And if you choose to go down this path with workspaces, you really need to think things through and make sure you know all the limitations in order not to regret this decision later. Another thing about workspaces is that I want to quote something from the Terraform documentation. So they say that to use workspaces to manage multiple non-overlapping groups of resources with the same configuration. So as I showed before, it suggests that these usages are qualified, right? Multiple environments, dev state in production, multiple regions or locations, or multiple accounts or subscriptions, as I showed before. All good by now. But also from Terraform documentation, they say that multiple deployments of the same infrastructure serving different development stages, aka staging versus production, named workspaces are not a suitable isolation mechanism for this scenario. So I don't know, in my entire career, I haven't never dealt with infrastructure that served both dev and production. It was always separated. So I'm not sure if they meant that or not. But if it raised the question for me, maybe it will raise a question for you as well. So just, again, another thing to bear in mind when you work with workspaces. And at least we can all agree on one useful workspace usage is like a side branch. So for example, a developer working on a complex set of infrastructure changes might create a new temporary workspace in order to freely experiment with changes without affecting the default name, the default workspace. So I can create new workspace, test everything out. Once everything looks okay, then I can apply the changes on the default workspace, which is production. So the good thing about structuring your Terraform code base and in a way that you really plan ahead things and you really think things through is that it will allow you to set up small state files and to set up Terraform as a platform in which in the long run and when you want to scale, it's very easy and you don't really need to do a lot of things because all of the things that I explained before. The bad thing is that sometimes organizational changes might require you to restructure the code, and we don't want that. We want to structure the Terraform code base in a way that makes sense to us, and in a way that will make us introduce changes that are planned and controlled, as opposed to, hey, organizational changes might require us to do changes. So that's about that. And another bad thing is to use workspaces for the wrong reasons, like I explained just a sec before. The ugly thing is really, if you structure the code base in a way that will allow huge state files, there's no way out, really. You will have invalid dependencies, big blast radius. You will change X, you will see in the plan output, it will destroy Y, and then really, Y is going to destroy it. Try really to avoid that and have small states set up as much as possible. The next section is Terraform execution. So we don't want, I mean, if we have Terraform being executed locally, then it means we need to set up local credentials, local configurations, and we don't have audits of what we're doing, right? Which is not that great. So if we use Terraform remote execution, then we avoid the need to have local credentials, local configurations, and we have this audit. So that's a good thing also for scaling teams, right? Because everyone can use it, and you will have this remote execution where everyone uses it the same way. Another thing is that you should use Terraform apply with the plan file, because you can set up a flag -- plan file, and then you know exactly what is being applied, and set up Terraform a timeout that makes sense to you, because for example, I had a scenario where I needed to create auto-scaling group with spot instances, and I selected a price that wasn't right, and then I had to wait and wait and wait until the timeout. So just make sure the timeout is set to something that is reasonable for you. The bad thing is to really execute locally, because again, You need local credentials, configurations, and no audits whatsoever. And also another thing that I want to mention about the remote execution is that, as I said before, if you execute and you run Terraform apply, then you will need to have Terraform state file lock, right? Because to make sure that nobody else does any changes during your changes. And if you have remote execution, then you can leverage tools to help you with the state lock. So for example, we use Atlantis, and Atlantis, when I run the Terraform apply through Atlantis apply, then it handles the lock for me. So if someone else opens a PR and on the same state file and they try to run, then it will say, hey, sorry, someone else's, another PR is running, wait for your turn, and that's that. So that's another reason why to have a Terraform remote execution. So back to route, the bad thing is to execute locally, and the ugly thing is to execute locally and run Control-C while you run a Terraform apply, because trust me, it will mess up your state. When I just started out with Terraform, I didn't want to wait for the timeout because it was very long. I didn't set up a Terraform timeout, and then I just ran Control-C and it messed up my state. So I don't know if it was fixed by now or not, but trust me, I don't want to find out. So just try to avoid that, because especially if you don't have Terraform state files versioning, then if the state file gets messed up, it's very hard to recover from that. Okay, so the last section that I want to cover here is basically the section that I had this build up throughout this presentation, practices enforcement. So we want to check if the code is in a high quality state, right? We want to check if the code is clean, if it's reusable, if resources are tagged, if the code is readable. So we basically can do all of this and any other guidelines that you want to set up through practices enforcement, through GitHub Actions or a CI pipeline check. We'll cover it in a bit. So modules should follow practices of readability and cleanliness of the code. But also, again, you can set up any guidelines that you want. For example, you can alert FinOps team if the infra cost is more than $10,000, for example. And in order to keep that all in check, we need to use enforcers. And I'm going to show an example how to do it from, again, community modules. So this is an example from a community model of the Terraform AWS autoscaling. And as you can see, there were checks that are introduced here to make sure that the contributor for the repository, for the module, they check if there is a format for the code through Terraform FMT, if the contributor added documentation, and if the contributor added a working code through TFLint. But also TFLint is not only to make sure working code the code is working, but also to have best practices, because TFLint also checks if, for example, you set up modules, but you didn't specify version for the version lock. So it will fail the check on that. Hey, you didn't lock the version. So it's really awesome to set up these checks, including TFLint, because it will really help you maintain a high quality of the code. So this is an example for the community models, but again, you should do it for your internal models as well. And these simple checks can easily remind developers to keep a high quality standard of PR as best as possible. So the good thing is to have pre-merge linters, formatters, and logical checks. You can do it with GitHub Actions. We do it here in Wix with the GitHub Actions. You can do it with CI pipeline checks as well. You can create a Slack bot to detect any drifts, or you can do what we do in Wix, in which we leverage Atlantis, which is an open, I mentioned it before, I will explain it now if it wasn't clear. Atlantis is an open source tool for Terraform pull request automation. So Atlantis, as I mentioned before, handles the Terraform lock, but also it makes sure that the main branch equals to the actual state of the environment. Because whenever I open a PR whenever I open a PR, Atlantis runs the plan. I see the output. I see that everything looks good. And then I type Atlantis apply. When I do this, two things happen. First of all, the code gets merged to master, and then it master main, and then it gets applied, Terraform apply. And that way, we know exactly that the main equals the actual environment, and then we don't need the Slackbot drift reporter because there are no drifts when this practice is enforced. The bad and the ugly here is not about practices enforcement, but about if you don't have practices enforcement. So you could face security issues, and you can face a non-compliant configuration introduced to your code base. So in order to help you introduce practices enforcement in your code base and help you in this journey, you can see here on the right, open source enforcement and helpers tools that will help you in this journey. For cost management, you have InfraCost, TerraTest, TerraTag, so a lot of tools that can help you achieve great practices enforcement for your needs. So I covered a lot of things here, right? A lot of things, but I want to get back to the question that I asked you before. How do you envision the infrastructure and the company needs? This is a very important question because this will shape how you structure things, how you address things, and basically this is the lighthouse approach that you should have. So you should think things through, and planning ahead will allow you to enable others on their Terraform journey, and you will be able to set up guidelines and best practices of your own, like tagging usage, as I showed before, that without tagging, the PR will fail to merge, structuring models, and TF utilization by others. So basically, these are the key takeaways that I want you to take out of this presentation. I hope that it's big enough. If not, I will make it bigger next time. So code-based structure to set it up correctly, to have Terraform as a platform, and small state files to take into, really, you have to take into consideration use cases, pain points, Terraform constraints, where do you see the infrastructure management and the company's needs in the long term, and plan accordingly. So these things will be applicable, because if we wouldn't plan ahead, we wouldn't be able to set up Terraform as a platform as we did in Wix. And even if you're a startup, think about scale. How should you address and prepare for changes to come? And then you will be able to utilize Terraform in the best way possible in order to enable infrastructure scaling and team scaling. And lastly, I want to quote another thing from the article that I mentioned before by Tisin Ur. He said that, and I really, again, it's a very good article, please read it. He said that programs evolve and code changes, and it's really uncommon that you write Terraform code and it stays the same, because this is not how projects work. If that was the case, I wouldn't even be here talking about Terraform practices, because everyone would just use it the same way, write the code, and continue with our lives. But we will always have projects, because businesses want to improve, and changing from the current state to the next desired state is a project. So think about how you structure Terraform code base and treat Terraform generally, because that way you will allow projects to evolve and get introduced, helping your company improve and contribute to the company's success, and enable infrastructure scaling and your team scaling as well. So these are references that I used throughout my presentation, some references about tagging, the documentation about workspaces that I mentioned, Tisin Ur, a great blog post, and Superlinter, which is another bundle of checks for the practices enforcement. So thank you so much. And I know that we have a lot of questions, so let's get right to it. Thank you so much.
Thank you so much, Hila. It was amazing. And just looking at how many questions we have and how engaged everyone is, I think that was a super successful topic. So thank you, and hope you get better. Somebody asked to go to the previous slide if you may for the references, but let's start with the questions. We have 22 of those, and guys, if we don't have time to answer everything, I have the log of all the questions, so I'll just post them in the platform engineering Slack channel, and ask Hila to answer those there. But Let's get going. Did you experience a multi-cloud Terraform setup, like providing the same module for AWS and Azure? Do you have learnings to share from that?
So no, I haven't dealt with multi-cloud, but we need to address that. I mean, as you know, the AWS provider works differently than the Azure provider. They were built differently. So unfortunately, I don't have any practices to say about that. Let me think if I can think about something. Just, I would say, first of all, map whatever you need, like the needed infrastructure, because maybe not all infrastructure needs to be a multi-cloud, maybe only a certain thing for redundancy purposes, for example. So do a mapping for what is needed to be multi-cloud, and then try to do and build a Terraform in a way that will be as generic as possible, and then build on top of that the providers. So if we need to do something, we should do it the same thing for AWS and Azure or any other cloud provider as much as possible, of course, because again, every provider is different. But if we have these guidelines to be as generic as possible, then we can leverage it to implement it for every cloud provider accordingly.
Thank you. More of the fun question, which popular provider that you used so far would you tag as the worst?
For now, I mean, until now, I used only AWS and, I mean, cloud providers wise, I used AWS and GCP. Other providers that I use are Kubernetes, Helm, the one for the, oh, it's called, forgot. The one, I forgot the name. I can search for it later. So the worst one, okay, I forgot. Okay, I also forgot. I used the Terraform provider of IBM Cloud, and I'm sorry, but I believe this was the worst one. It had a lot of issues, in a way that we just chose to neglect Terraform and move to Python because of all of the issues that we had. So I'm sorry, IBM Cloud, and I hope that you improved since then.
We hope to. Do you recommend using Terraform Cloud or alternative cloud-based ones for state management?
So I haven't personally used Terraform Cloud. I only used the Terraform open source one. So in order to address that, I would, again, mapping and doing research is very important because we need to understand if what the product has to offer really fits our use cases. And in order to know what our use cases, we need to do the research. So we need to first understand the use cases and then check Terraform Cloud, check maybe the Terraform open source is good enough and we don't really need the cloud and pay money for that. So based on that and based on the research that we will do, then we will decide on the proper product to use. So again, I haven't used Terraform Cloud, but if I would need to do something, I would again do the research and then do a review of all alternatives to make sure which one is the best suit, has the best suitability for my use cases.
Can you repeat the provider that you mentioned in the previous answer? Because
it will kill me.
Krasimir is asking again. He says that he couldn't hear, but I don't know. We can include it in the follow-up as well.
IBM Cloud is to create resources in the IBM Cloud. So it was, again, I dealt with it like in 2018. So maybe they improved by then, I don't know. But back then it was very hard to create Terraform resources for IBM Cloud because the provider had a lot of issues.
Yeah, we're not saying that they're ugly now.
I don't know. I have no idea.
Yes.
I only did that on it in 2018. Maybe since then they improved a lot. I have no idea.
Yes. Would it be better to create wrapper on top of community module and have ability for own customization?
I would use a wrapper mostly for workspaces because of what I mentioned with the way that we change workspaces is with CLI, and if I forgot to do the change, then it's very problematic. to run models, I never experienced any need to have a wrapper for that, because if you reach a point where you need to do, I mean, why should you use a wrapper if you want to, for example, have conditions like I want to apply Terraform, but only for this target, because you can pass a minus target and only apply from the entire code base. You can from the entire model, you can apply only one resource or one model. So then you need to pass the flag. But if you reach this point, probably the way that you have the structure currently is not the good one, because you shouldn't use target a lot. And I wouldn't use a wrapper for models run only if I don't need to run specific models in a certain point. And if I do need to do it, it's because something is structured poorly, in my opinion. So no, I wouldn't use a wrapper to run models only for workspaces, to run Terraform when we use workspaces. And if we use models, then just run Terraform apply. And if you have small state files, then it's very awesome. We know exactly what is being applied. The plan output also will be quite small. So if you have small state files set up, you don't need a wrapper for that.
Thank you. So just to be mindful of your time, Hila, can you spare another 10-15 minutes? Yes.
No
Okay, perfect. Let's get going. PMR or service catalogs for custom modules, which is the best practice?
Again, can you repeat that?
Sure. PMR or service catalogs for custom modules, which is the best practice?
PMR, you said?
Mm-hmm. Yeah, PMR. Probably.
I don't know what PMR is. I'm sorry.
Let's move on to the next one.
Yeah, I'm sorry. If you want to elaborate on the Slack channel or now, if you're here, then awesome. But I don't know what PMR is. I'm not sure what are these initials.
Yes, Daniel, please, if you're still here, add your comments. Another question. We have over 30K individual cloud resources in Azure. We have a multi-layer single code-based Terraform setup managed with CMake and TerraGrant. With Terraform framework structure, would you propose for running Terraform at scale? What other useful tools would you recommend to help with easier, better management?
Okay, so another thing that we do in Wix, which I haven't mentioned in my talk, is that on the live side where we call the models, we only have models. I mean, we only call the models. We don't have standalone resources. Why? Because for better management, we want to have like capped and contained workloads, and then we know exactly what is being run. We are it's not all over the place. Everything is by models, and that's that. So this is one thing I really encourage you to do. Take all the resources that you said that they are flat, like 30 resources, and divide them to models, and then just call these models. And then the management will be very easy to do, because everything is capped. You have defined workloads that you can apply and use and reuse, and that way it will be very easy to use in the long run, and also for scaling, because everything is kept and very organized, and you don't have like flat resources that you're not sure which dependent on which, and that's a good practice. We have it in Wix, and it works very good for us, very well for us.
Thank you. And referring to the previous question, so PMR is private model registry, which should be in Terraform Cloud, and service catalog GCP specific. So to get back to the question, for custom modules, which of the two is the best practice?
So currently, we have our private models, like the custom models, local in our repository, but we are considering to switch to Terraform Cloud just for that, just to have the models kept there and then fetched from there. We haven't done that yet. So it really, I would say, depends on the scale, the amount of models that you have. So based on that, I would make this decision. So, I mean, the two options are either to keep it in the same repository or just move these models to Terraform Cloud to keep it there.
And Daniel specifies bucket base, so depending on the number of buckets, right?
Okay. Yeah, I mean, I didn't experience too much issues with that. So.
Got it. Thank you. The next question, what would you suggest for optimizing execution of Terraform plan and apply? I've tested parallelism and it works fine. Is there anything else from your experience with other parameters or options?
So in my experience, parallelism is good when you have, you really need this parallelism to make sure that Terraform runs like quicker and not reach timeout because they run in not enough threads in parallel. But again, if you have small state files, you don't really need this parallelism because small state files is a very small workload. So you don't really need this parallelism because it will execute pretty quickly. And then what we have in Wix, where we have Atlantis to execute Terraform for us, this is awesome because it executes whenever I open the PR, it runs, Atlantis runs the plan. I see the output in the GitHub PR itself. And then after I got the approval on the PR and I check the output and I see that everything is good, I just execute Atlantis fly and it gets executed. And I haven't experienced any issues with the need to have parallelism once the small state files are set. So I would say that the issue with parallelism is mostly when you have huge state files and then it takes a lot of time to execute. But if you will switch to small state files, then it will be the best way to go. It will get executed quickly. You wouldn't have invalid dependencies that, like I explained before. So for me, it's the way to go, especially if we need to scale up.
Thank you. The next question, can you please explain how code reusable will work as a best practice?
Code reusable, so if we think about models, so as I explained in the presentation, if we have a complex module, then we can break it down to submodules, and then we can reuse these submodules without the need to use the entire module, because these submodules are standalone of their own. They are part of a module, but since they are a submodule, I can still reuse them and create the resources for these submodule only. So this is for modules. Other usage examples that I can share with you, for example, is that I just did it now at work. I use the community model for the S3 bucket creation, and the model in its current state only allows to pass one policy. So it means that if I need to create 20 buckets, I need to call the model 20 times, but also create the policy document data source 20 times, because it's one-to-one. I can only pass one policy to the bucket. So what I did in order to not repeat myself and reuse the data for all buckets that I need, I created the data source policy document dynamically. So all the blocks are dynamically, like the principal and the resources and the actions, everything is dynamic. And then the only thing that I add is in the locals that I have. I set up the policy in the locals, and then the data source of the policy document looks at the locals, and based on the key for the bucket, just regenerates a policy. So that way I have calls, module calls for each bucket, but I have only one definition of data source of the policy document, only once, and it checks the locals for each key of the bucket and regenerates the policy. And that way I didn't need to repeat myself and create the data policy for each bucket. And trust me, and if you use the policy document data source, it can get very big. So I have it only set up once, and the only thing that will get bigger is the locals. Every time that we need to create a new bucket, we just add a new key and value. For key is the bucket, value is the entire statement for the policy of the bucket. We just add it, and that's it, and it's very easy to maintain that way.
Thank you. I guess let's do this. The final question, since we have a ton, and I see quite a few people dropped off already, but I don't know, you tell me, Hila, how long you can go. I can also copy the questions and post it in the platform engineering Slack channel after. What would you prefer, to answer live or to answer in Slack?
Let's continue live, and if I have things that maybe I don't know, I can go back to them and then reply on Slack. So let's see.
Amazing. Okay, let's keep going. How would you manage multiple different teams using Terraform in a large company? How would you split the work between them? Would you consider all teams using the same code base, or would you prefer to have specialized teams over specific types of resources environments?
I pretty much covered it in the presentation. I don't know when they asked this this question, but I will repeat it briefly. So the structure that we have in Wix is that we start with team and then project and blah, blah. So each team has their root folder. So they are in charge of their folder, and they have complete autonomy. They can approve their own PRs. And that way they are all in the same repository, which is good because they can leverage our models and have references for everything that they need out of the box. What else did I don't remember what else did I say, but basically it. And so just watch the presentation again for this.
We'll send over slides as well, so
yeah,
they can also check it out.
That's the thing. Since we have the repository, all teams are on the same repository. New teams can just join and create their own root folder and enjoy the practices and enforcement that we have applied for all the code base, etc. So I recommend this for team scaling. It works well for us. Trust me, we have a lot of teams in Wix, and everyone uses the same code base. It works perfectly. We have their autonomy for our code, and we don't experience bottlenecks because of that. But of course, if I change the code for my team, then my team alone is responsible for that, and they can improve my PRs. But if I change models, right, that are used by entire other teams as well, then the code owners of GitHub adds relevant people to approve the change, because this change is more broad, and not only for my team, but other teams as well. And that way we make sure that other teams are aware of this change. They can check for backward compatibility to make sure that nothing was break because of the change. So that's why it's really good to have a lot of teams structured on the same code base and leverage code owners for that. It works perfectly, and everyone is happy.
Yeah, there is another question. When you were explaining the structure, why would team be the first level of your code base hierarchy, considering a company's goal should be to provide less knowledge silos, make teams interreplaceable?
Wait, I lost you a bit. So the company.
I can repeat it.
Yeah, what company's goal is what?
The company's goal should be to provide less knowledge silos, make teams interreplaceable.
But there is no knowledge silos, because the code repository is available to everyone to see and use and reference. If I want to, and I basically did it, when I wanted to restructure my subnets in my VPC, in my account, I checked in other teams how it's being done. I searched in the Visual Studio Code VPC, and then I checked other teams how they do it. So quite the contrary, there is no knowledge silos, because the code is exposed for all teams to use because we are all on the same repository. So I can just go to other teams' folders, see references and how they did things there, and that's awesome. So knowledge sharing is here, and I value knowledge sharing a lot, and this actually helps me do it. And because the code is there, and because I have these references, also we have Git blame in the Visual Studio Code. So if someone added the relevant module, I can see who added it and go to Slack and ask this person like follow-up questions. Why did you do this like that? And stuff like that. So on the contrary, it encourages knowledge sharing and collaboration because I can see what others done and have follow-up questions if I need to.
Nice. Next question. Are live and modules within the same code base, or are modules decoupled?
Yeah, so the code base is, so I mean, I said it starts with teams, but as I showed in the example afterwards, we have live and modules, and then in live, we have the team. So live and modules currently are on the same repository. As I mentioned, we are maybe thinking about taking the modules outside to put them, to store them in Terraform Cloud, but currently we have them all in the same repository. I don't see any problem with that. Yeah, so yeah, they are on the same repository for now. For a lot of time. Yeah.
It works, guys. How does the monorepo structure compare against the multi-repo one? You could probably share code across repos with custom Terraform modules.
I think what the person meant to say is that since I have small state files, then how, if I need something from the other state, how do I use it, right? So I think this is how I understood the question. So we can use Terraform workspace, Terraform remote state resource, and then address other, and basically fetch other state resources on my state file. And that way I can reuse other people's state files and reference them in my code. So I don't see any problem with that. And I don't see, I mean, this wouldn't be the reason for me to split the code throughout different repositories. This wouldn't be the reason for that. It works perfectly. We leverage adult state files with the remote state. We also keep stuff in console, and also another product by HashiCorp. We keep things in console. We also query a console for that. So I wouldn't go splitting the code base if that's the reason that you're considering to do it for.
Thank you. How do you know which environment has changed with the limited blast radius solution? Do you recursively iterate over the folders, then run Terraform plan apply? I like the idea of limiting the blast radius, but would like to understand how do you apply changes?
So again, as I showed in the presentation, it's a team project, cloud provider, and region. So the last level is the region. So if I apply to region X, there are no drifts, there are no like other things to worry about, because I know that I only apply to this region for this project and this project resources in this region and for this team. So it's very, very small and contained, and that way I don't really have any concern that I'm affecting other things, because state file is very, very small and I know exactly what is contained in that.
Thank you. Yes, guys, read watch presentations again. Just kidding. What would you recommend as a good non-destructive way to operate Terraform providers?
What do you mean to operate Terraform providers?
Upgrade.
Upgrade. that's a good question. It needs to be done. I mean, also, again, state files small, the blast radius will be smaller than usual, and then we can, for example, create a workspace, upgrade the version, see if there are any issues like, hey, the syntax is wrong and we don't support that, and maybe changing the syntax will create other issues. So if you have small state files, then you can also upgrade the resources for and the providers much more gradually, and that way you can do it in a safer way, because as long as it's gradual, then it's more safe to do. So small state files, less resources per each state equals less resources that are managed in that provider. So if we upgrade this provider, we know exactly, we can test it on these resources in workspace, not to affect production, of course, do it on the side, make sure that everything looks good, no, the backward compatibility is preserved, and then we can continue to the next provider in line based on the projects that we have.
Right, thank you. And the following question, what are the best practices to be followed while importing existing resources into Terraform? Any reference document on best practices based on previous Terraform implementations?
That's an interesting question. I don't think, I haven't seen any documentation about that. I can share how I do importing of resources. So again, we need to scope it as much as possible and not have like a bundle of things. If we cap it to a project, we know exactly which resources are needed. Then I create the code that is necessary, because how you do the import, you first need to create a code, run Terraform plan, see what it's going to create, and then start to import based on each resource. So as long as everything comes back to small state files, I'm sorry. So as long as the state file is small, then you have less resources and they are kept. And then you create either the resources or preferably the module to create these resources, run plan, and start to import each one individually. So if, for example, the code that you created will create 10 resources, start one by one, import the first one, then the second, and then the desired state should be when you run the code and you have 0 changes. That way you know exactly that everything that you imported is referenced correctly by Terraform, and then it means that Terraform now manages these resources. So this is how I do it in my day-to-day. It works, it's safe. So yeah, this is what I suggest.
Thank you. What would you recommend for managing resource logs only on specific resources in a Terraform project?
Lock only specific resources? You mean ignore changes? I'm not sure. What do you mean specific resources lock? Because for specific resources, it means that, hey, if I change the max size for auto-scaling, like min-max, then if I ignore it, then if someone changes it, then it wouldn't get applied. This comes to mind, but I'm not sure what the person meant by specific resources lock. As far as I know, you can't lock specific resources, only a state file. This is what I know, but if the person would like to elaborate more in the Slack channel, then I would maybe more able to help them.
Yes, please clarify that question if you can. Next question, remote execution in CI/CD on a VCS push or similar, or Terraform cloud? I don't understand this question, but maybe you do.
Yes. I'm not sure what they meant by VCS. Again, people, not all initials are known to everyone. But I didn't use Terraform Cloud, so I can't really attest to it. But if you use, generally speaking, if you use CI/CD, you have to do Terraform execution. I mean, it's not really remote, because if you run a CI/CD, then the tool itself needs to run Terraform. But the fact that you have CI/CD means it's remote, because only preferably only the Jenkins or any other tool runs the Terraform apply, and not you on your machines. So basically, the remote execution is having a CI/CD pipeline that runs a Terraform for you. So that's just a sec. I have some notification about work. So just a sec. Okay. Okay. So that's based in regards to that. If you don't want to do a Terraform pull request automation like we do with Atlantis, then at least have CI/CD that runs Terraform for you and don't run it locally. But again, I haven't used Terraform Cloud, so I can't attest to that.
Thank you. Next question is, any best practices to handle table level changes, which calls for drop and recreate resource, for example, BigQuery table partitioning or cluster column add, which doesn't bring changes to data, but to structure. In my opinion, it drops the table and recreates, and data is lost. Have you come across this situation?
No. I'm sorry. I only
move on.
Yeah, I'm sorry. I only dealt. I created the module to create BigQuery, but I didn't had any use case back then to handle tables in that level. So I'm sorry, I don't have experience with that.
Next question: what is the best extension to be added to VC code to produce the topologies?
Topologies of what? I'm not sure which topologies the person refers to. In general, I used the Terraform plugin to have highlighting of the code, and to make sure that if I click enter, then it creates the proper indentation. But I'm not sure what they meant by topologies.
Yes, if you want, you can clarify in the platform engineering channel later, or I don't know. Today, next question: can you recommend a good resource web or book for learning Terraform as a beginner having experience with AWS?
I saw lately that the creator of TerraGrant released a book. So he's pretty known. I forgot his name, I'm sorry. But just search for the creator of TerraGrant and you'll see it. And he released a book, and I think I haven't read it, but based on other opinions that I heard, then it's a good book. So this is one thing. And another thing is that I mentioned Anton Babenko. He's, again, a Terraform celeb. So he has a site called Terraform Best Practices, which gathers a lot of best practices about Terraform. So it is a very good resource for you to use. And because Anton has a lot of experience with Terraform, so just go to Terraform Best Practices by Anton Babenko, and you will have a lot of best practices addressed there as well.
Nice, and I see some editors also recommend their favorite books, so take a look. Have you got a chance to work with multi-account setup from any of the providers?
Small account setup with the provider?
Multi-account setup.
So basically, it's a repeat of the question from the beginning about multi-cloud. So I haven't used multi-cloud. So the answer is no, unfortunately. But hey, we can raise it as a question in the community, and I assume others will be able to pitch in.
Yes. How do you keep track of resources created manually and resources created through Terraform?
So through Terraform, as I mentioned, we always use the default tags of managed by Terraform, and that way all tags through that provider is automatically tagged by Terraform, and we know that. Manually, this is a pain for everyone to find resources that were created manually. It's very hard. I don't recommend it at all to create manual things. I mean, if you do a POC, then you can create manually just to make sure to test things and see if the solution works. But if you do it for POC or any other purposes, have a documentation of what you exactly created. So A, you will be able to create it afterwards through Terraform, and B, if the POC was a failure, then you know exactly what needs to be deleted. So I would say that, I mean, through Terraform, it makes it very easy to use because of the tagging, but when you do it manually, if you go down this path, you need to be fully aware that it's very hard to maintain, and that's why you need to have a proper documentation that documents exactly what you created manually.
Amazing. And I guess the last question, with small state files, and if they are imported in other module, how do you manage the change in the module importing state when eventually the imported state changes? In other words, how do you trigger the change in the module importing state when it changes?
That's a good question. I haven't experienced that yet. I mean, that in the dependent state, there was a breaking change for my state. I haven't experienced that yet. Let me think if I have something out of the bat. So maybe for things that you know that will change frequently, then don't use that method, but use console, because the thing with console is that it's like a dynamic reference to something, because you can reference to a service, and then console on its own knows exactly which servers or endpoints are equivalent to that service endpoint. So maybe for that use case, I would use a console and not a state file to make sure that I get the dynamic result. And once it is done through console, you can't really introduce a breaking change, because console expects something to happen, right? If console manages a service endpoint, then it expects to have the service endpoint reachable. So if it's not reachable, then console, as a way of being console, will mark it as unreachable, and with all the consequences based on that. So I would say, to some example, I would say that maybe for certain cases, I wouldn't use the state file importing or referencing, more accurate to say, but use a console for that.
Amazing. And we're running for 1.5 hours, Hila.
Oh.
Thank you so much for your time. Thank you so much for your time, guys. Everyone who attended and stayed up with us for so long. I am sure that everyone has to go back to their work and a little bit tired. Hila, please get better. And on the housekeeping notes, we will send out the presentation slides and the webinar replay tomorrow morning. Other than that, thank you so much, everyone, and we'll see you next week.
Awesome. And really, thank you everyone for staying with us. I hope that means that it was beneficial for you, and Terraform is a great tool, and I hope that I was able to give you more value through this session. So thank you for staying with us. Thanks, Maria and Platform Engineering, for having me, and see you soon.
Thank you for this great branding, the t-shirt, the background again. I need to get prepared better next time.
And buy also the croissant white, it's very cute.
Yeah, you can find the Platform Engineering store at the platformengineering.org if you guys are interested. I personally love the socks with the little croissants. But yeah, see you next week. Have a great one. Bye.